Okay, so this video is specifically on how to use your transformation chart and what everything like means. Okay, so we'll start off with we know a function. So this F right here, parentheses, right? You will notice that this is in black, right? So f of x, this is the function that we use. Okay, so basically it's like a game, right? Once you know the rules, then you know what any function I give you, how it transforms. And you can tell me how just by observing what it's doing. Okay, so you will notice that right here. So let's start off with the negative, right? So we have a few different things that can happen. So if I have a negative outside of the parentheses, you will see right here, it says outside of the parentheses, then that means a reflection across the x-axis. So anytime you see a negative outside the parentheses, right, you're going to see something like this. Whatever function I give you, it's going to be a reflection across the x-axis. And this is what that would look like. This is just an example. I grabbed a parent function that I thought was pretty easy to read, right? So we're using the vertex, and you can see that the vertex doesn't change. The only thing that happens is that it's flipping upside down. So that's what it's going to do. Now for this bottom part, right? Now you will notice here, the negative is inside the parentheses, right? So I have parentheses, whatever I give you, it depends on the parent function. And you will see that a little more clearly once we do other functions. Okay, so if it's inside the parentheses, then it's going to be a reflection across the y-axis. Now, for quadratics, that picture didn't work. So I used a cubic function instead, because you can see that the black starts down here and then it goes up, right? So if it's a reflection across the y-axis, it goes this way, right? Instead of going downwards, it's going, so it was going to the right, now it's going to the left, right? It's a reflection across the y-axis, and it was a little easier to see that here and what that would look like. Okay, so that's a reflection. Now, you will notice, let's focus on this half of the graph, okay? So you will notice that up here, I wrote vertical, vertical, horizontal, horizontal, okay? Now, let's see why that makes sense, okay? So notice that right here, both of these, this B and this H, both of these transformations happen inside the parentheses, right? And what letter or what variable is being affected inside the parentheses? Well, it's X. And what direction does X travel? Left and right. So you know that when you have a number inside of the parentheses, it's going to have to be some type of horizontal transformation, whether physically shifting left and right, or whether the name is going to have horizontal. Okay, so that's just like a helpful way to remember what type of transformation it is. Then over here, you will notice it says vertical anytime it's outside the parentheses, right? Now, let's make sense of that part. So if I have, right, one of the things you learned from function notation in whatever math class you were in, right? Hopefully it was algebra 1. But we know that f of x is equal to y, right? So if we know that f of x is equal to y, then that means that I'm multiplying a to f of x, which is really y. And what direction does y travel in? Well, it travels in up and down, right? Which is why it would make sense that that transformation would be vertical. Okay, so so that's the first thing, right? So this is helpful because it'll help you differentiate between what transformations you're even looking at. Now, the other thing we need to distinguish is the difference between adding and subtracting and multiplying, right? Obviously, we know that it's multiplying if it's literally right next to our variable or our function or our symbol, whatever. And obviously, if it's adding or subtracting, we're going to see a plus or minus sign, right? Whether it's to inside the function itself, right? Inside, or if it's going to be added to the end. Okay. So now after analyzing that part, let's go to one at a time. So right here we have A. and it's multiplying to the whole function itself, right? And it's going to be outside the parentheses. If A is greater than 1, then it's going to be a vertical stretch, right? And if we think about what a vertical stretch even is or what that looks like, so if I grab this circle looking band looking thing, right? And I place my hands vertically, right? That's up and down. And I stretch it, the opening here is more narrow, right? So a vertical stretch, skinny, narrow. Okay, so let's look at the B at the same time. So if your B is inside the parentheses and that B here that you physically see is greater than 1, it's also gonna be narrow, but the name is different, right? So it's gonna be a horizontal compression. So now my hands are horizontally, and compress means to push, right? And you can see that the opening is also becoming more narrow. Okay, so that is why these two things, even though named differently, they do the exact same thing. Okay, so basically look at it as this way. Anything that happens inside is always going to be opposite of what happens outside, right? So it's going to look different, right? But for these two right here, that's the name and that's what it's going to look like and that's what it's doing. So we have the parent function and what it's physically doing. So similarly, right here, you will notice that if A is between 0 and 1, right, which basically means like a proper fraction, right? So 1/2, 1/3, 3/4, not improper fractions, right? If I were to put 4/3, that's greater than 1, that would automatically be in this category, okay? So basically 0 point something, okay? And that's going to be a vertical compression. So let's think about what vertical compressions look like, right? So if I have my liga right here, I'm vertically placing my hands, and if I compress it, we can see that the opening here is widening, right? It's going side to side. It's getting bigger on the sides. So it's going to be wider, fatter, okay? Similarly, if you have your B and it's multiplying inside the parentheses, it's going to be a horizontal stretch. So if I do the same thing, horizontal, now my hands are side to side and I stretch it, you can see that it's widening on the sides, right? It's getting wider. So a horizontal stretch and a vertical compression look the exact same, right? It's going to grab the original and it's going to widen it. Now, for your horizontal and vertical, when you're adding and subtracting, right? So let's look, for these, we're going to look at them one at a time, okay? So if we're looking at an x minus h, right? And it's inside the parentheses, think opposite. So I know that our negative numbers are on the left side, but because it's inside the parentheses, it's actually going to go to the right. How many ever units is there? Right? So here's the original and it's actually going to go to the right. So then if a minus is going to the right, then obviously an addition would be going to the left, however many units. And then for this one, because it's outside the parentheses, and this is going to be as is. So if it's a minus k, it's going to go down so many units, right? And then if it's a plus k, it's going to go up so many units. And that is how you read your transformation chart. Okay.